All right, grab your coffee, because we've got a case to crack. And trust me, it's a classic. One of those frustrating mysteries that probably lands on your desk way more often than you'd like. The case of the mysteriously slow serverless function. So let's open up this file and see what we've got. So you know the feeling, right? The alert comes in, your P99 latency is just spiking. Users are complaining, the support tickets are piling up, and you know that every single second of that delay could be an abandoned shopping cart or maybe a customer just losing trust in your product. You look at your function and it's just slow. But why? I mean, is it your code, a misconfiguration somewhere, a downstream service that's acting up? Honestly, it can feel like you're searching for a needle in a haystack, especially when that haystack is this giant, globally distributed, ephemeral cloud environment. Right, so this is the real kicker. The very thing that makes serverless so amazing, the agility, the abstraction, that's also the exact thing that can make it a total nightmare to debug. We've basically traded in our predictable, comfortable, stateful servers for something that, let's be honest, often feels like a complete black box. And this comparison, it lays it all out perfectly. Back in the day with traditional apps, you could just SSH into a server, check the CPU, tail a log file. Everything was pretty predictable. But now, with serverless, we've got these functions that spin up and vanish in milliseconds, triggered by this complex web of distributed events. It's a whole different ballgame. The old monitoring playbook? Yeah, it just doesn't work anymore. So the big question is, how do we crack this black box, right? Well, we need a modern investigator's toolkit. And for any architect working in the cloud today, that toolkit is absolutely built on what we call the 3 pillars of observability: metrics, traces, and logs. Think of these as our forensic tools for the digital world. First up, we've got metrics. Now, these are your high-level signals. We're talking aggregated numbers like latency, error rates, invocation counts. Metrics are kind of like that first call you get from the crime scene. They tell you that something bad happened, but they don't tell you who did it or why. They just give you that critical, high-level overview. Okay, so our next tool in the kit is traces. Now, if metrics tell you that something's wrong, traces are what tell you where it's wrong. A trace literally follows a single request on its entire journey, from the moment it hits the API gateway, through your Lambda function, out to a database, and all the way back. It's like having a perfectly reconstructed timeline of events that points you right to the bottleneck. And last but not least, we have the most granular piece of evidence you can get: logs. These are the detailed, time-stamped witness statements from a specific part of your system. An error message, a connection failure, a full stack trace. This is where you find the smoking gun. It's the ground truth that tells you exactly why the problem happened. Okay, so theory is great and all, but let's actually put this toolkit to work. We're going to open the real case file on our slow function and see exactly how these 3 pillars, metrics, traces, and logs, work together to solve this thing in the real world. So here's our game plan. It's a simple, logical process. Step 1, we'll use metrics to spot the anomaly. Step 2, we'll follow a trace to isolate where the delay is happening. And step 3, we'll dig into the logs to find that root cause. Okay, check this out. Here's our first clue straight from the metrics dashboard. Now, what's interesting here is the P50. That's the median latency. It's at a perfectly fine 150 milliseconds. So for most users, everything's great. But then you look at the P99 and whoa, 3.5 seconds. That's a huge difference. This tells us the problem is definitely real, but it's an outlier issue. It's only affecting a small but probably very frustrated group of users. So, naturally, we grab a trace from one of those really slow P99 requests. And this just lays it all out for us, doesn't it? The API gateway is super fast, 2 milliseconds. The Lambda init is fine, but look at that execution block, 3.3 seconds. And when we drill down into that, bam, almost the entire time, 3.1 seconds, is just waiting on a single external API call. We've just isolated the location of the crime. And just like that, we know exactly where to point our magnifying glass. We pull up the logs for that specific function invocation, and there it is, clear as day, our smoking gun, a connection timeout after 3,000 milliseconds to some external payment API. So think about it. We now know that there was a problem, we know where it was, and now we know exactly why it happened. And there you have it. The verdict is in. By moving systematically from our high-level metrics down to the specific trace and finally to the granular logs, we went from a super vague complaint of the function is slow to a precise, actionable root cause. That downstream payment API is our bottleneck. Case closed. Okay, but let's be real. In the real world, our apps are almost never this simple, are they? So what happens when your crime scene isn't just in AWS? What if it spans services across Azure and maybe Google Cloud too? Well, welcome to the multi-cloud challenge. I mean, just think about it. You have a request that starts in an Azure function, then it calls a service in GCP, and then it writes to a database in AWS. Suddenly, all your clues are scattered everywhere. You're dealing with inconsistent data formats, a bunch of separate tools that don't talk to each other, and you have absolutely no single unified view of what that request is actually doing. It's literally like trying to solve a case when your evidence is locked away in 3 different police precincts. So this all brings us to the final and maybe most important point. Look, cracking these cases after they happen is a super valuable skill, for sure. But the real goal is to prevent the crimes from happening in the first place. And that requires a fundamental shift in our thinking, moving away from just reactive debugging and toward proactive design. And this is the thing I really want you to take away from this. Observability isn't just a set of tools you pull out after something's already on fire. It's a design principle for your entire system. It's about building your applications from day one with the assumption that things will go wrong and giving them the built-in capability to answer deep, complex questions about themselves so you can understand why. And I'll leave you with this one question to take back to your own projects. Is your architecture observable by design or by accident? Seriously, think about it. And if you're not sure where to start, just try this. For the very next feature you build, make sure every new function emits at least one structured log with a unique request ID. It's a small step, I know, but it's the first step toward building a system where finding the clues is a core feature, not just a happy accident. The answer to that question makes all the difference.